video we are going to solve some more examples on matrices. Now the next example is matrix A is 4, 5, 2, 1. Then show that A inverse is equal to 1 upon 6 into the matrix A minus 5I. Therefore solution, here matrix A 4, 5, 2, 1. To find the inverse of matrix, we have to find determinant of A and adjoint of A. Therefore determinant of A, 4 into 1, 4, minus 2 into 5, minus 10, that is equal to minus 6. Then adjoint of A, we know that while writing the adjoint of A by using direct method, we have to interchange the diagonal elements. Therefore ओरिजिनल मॅट्रिक्समध्ये 4 1 आहेत तर आपल्याला ते लिहिताना 1 4 लिहायचे अँड नॉन डायगोनल एलिमेंट्स चेंजेस देअर साइन. देअरफॉर -2 -5. देअरफॉर A इनव्हर्स इज इक्वल टू adjoint of A divided by determinant of A, and therefore here is the matrix adjoint of A 1 -5 -2 4 and adjoint or determinant of A ची value आहे -6. And this we can write this as -1 upon 6 into the matrix. Now RHS is equal to 1 upon 6 into A minus 5I. This is equal to 1 upon 6 into matrix A is 1 upon 6 into matrix 4 5 2 1 minus 5 into identity matrix of same order, that is 1 0 0 1. Therefore 1 upon 6 into matrix 4 5 minus 2 into bracket I think minus, here we have multiplied all the elements of this matrix by 5, that is 5 0 0 5, and therefore it is equal to 1 upon 6 into 4 minus 5 5 minus 0 2 minus 0 1 minus 5. We have subtracted corresponding elements of second matrix from elements of first matrix, and therefore this is equal to 1 upon 6 into -1 5 2 -1 -4. Take -1 common from this matrix, and therefore -1 upon 6 or 1 upon -6 into the matrix 1 -5 -2 and 4. -1 कॉमन घेतो म्हणजेच काय आतल्या सगळ्या एलिमेंटला -1 न डिवाइड करतो, and therefore from equation 1 and 2 LHS is equal to RHS, and therefore A inverse is equal to 1 upon 6 into A into bracket A minus 5 into R. Now here is the next example. Find matrix X if A into X is equal to B, where A is the matrix of 3 by 3 order 1 2 3 -1 1 2 1 2 4, and B is the column matrix 1 2 3. Therefore the solution, given A into X is equal to B, therefore substitute the values of A and B. Now to find matrix X, we have to reduce matrix A into the identity matrix by using elementary row transformations, because A is the prefactor, and for that to reduce this -1 to 0 and 1 to 0, we have to perform these two operations. R2 transforms to R2 plus R1 and R3 changes to R3 minus R1, and therefore by here first row remains unchanged 1 2 3, second row R2 plus R1, therefore -1 plus 1 0, 1 plus 2 3, 2 plus 3 5, and R3 changes to R3 minus R1, that is 1 minus 1 1 minus 1 0, 2 minus 2 0, 4 minus 3 1, and 3 minus 1 2. Here also R2 minus R2 plus R1, that is 2 plus 1, 3. Now next task is to reduce these two elements to 0 by R1 changes to R1 minus 3R3 and R2 changes to R2 minus 5R3. Here 1 minus 3 into 0, that is equal to 1, 2 minus 3 into 0, that is equal to 2, and 3 minus 3 into 1, that is 3 minus 3, therefore this reduces to 0. Now here also R1 minus 3 into R3, R1 चा element आहे 1 minus 3 into R3 चा element आहे 2, that is 1 minus 6 minus 5. Now R2 changes to R2 minus 5R3. Now 0 minus 0, 0. 3 minus 5 into 0, 3. And 5 minus 5 into 1, that is equal to 5 minus 5, 0. Now here also 3 minus 5 into 2, that is 3 minus 10, therefore 7. 3 minus 10 minus 7. And therefore to reduce this element to 1, we have to perform R2 changes to 1 by 3 R2, and therefore we will get this step 1 2 0 0 1 0 0 0 1 into matrix X. Into right hand side also R2 चा element है minus 7, and therefore after dividing it by 3 we will get minus 7 by 3, therefore minus 5 minus 7 by 3 and 2. Now the next task is to reduce these two into 0, and therefore we have to perform R1 changes to R1 minus 2 R2, and therefore this matrix will reduce to identity matrix, because 1 minus 2, 2 minus 1 into 2, that is equal to 0, is equal to X, and therefore 5 minus 2 into minus 7 by 3. R2 and R3 remains unchanged, and therefore I into X. After solving this we will get 1 by 3 minus 7 by 3 and 2. We know that identity matrix into any matrix, that is equal to matrix itself, and therefore I into X is equal to X, and therefore X is equal to 1 by 3 minus 7 by 3 and 2. Here the example is, if matrix A is 2 3 1 2 and matrix B 1 0 3 1, then find matrix AB inverse. Also verify that AB inverse is equal to B inverse A inverse, that is inverse of the multiplication of two matrices is equal to inverse of first factor into inverse of pre-factor. So here is the solution, matrix A into B. The matrix multiplication तुम्हाला माहिती आहे, फर्स्ट रो फर्स्ट कॉलमचा एलिमेंट घेताना फर्स्ट मॅट्रिक्सचा फर्स्ट रो, सेकंड मॅट्रिक्सचा फर्स्ट कॉलम, अशी मल्टिप्लिकेशन घेऊन येणाऱ्या एलिमेंट्स रिझल्टची ॲडिशन करायची आहे. देअरफॉर 2 into 1 2 plus 3 into 3 9, 2 into 0 0 plus 3 into 1 3, 1 into 1 1 plus 2 into 3 6, 1 into 0 0 plus 2 into 1 2, and therefore resultant matrix is 11 3 7 2. Now to find the inverse of matrix we have to check determinant of matrix is not equal to 0. Therefore determinant of AB 11 into 2 22 minus 7 into 3 21, that is equal to 1. Now adjoint of AB, given matrix वरना adjoint आपण directly लिहू शकतो by shortcut method. Since here is the matrix AB, to write adjoint of AB we have to interchange the diagonal elements. That is, if in original matrix diagonal elements are 11 2, then we have to write 2 11, and non-diagonal elements changes their sign, that is minus 7 and minus 3. We know that inverse of matrix is equal to adjoint of matrix divided by determinant of matrix, and therefore AB inverse is equal to adjoint of AB divided by determinant AB, and therefore LHS is equal to matrix 2 minus 3 minus 7 11, and value of the determinant is 1, and therefore resultant matrix is 2 minus 3 minus 7 11. Now RHS आपण बघितली, आता LHS सॉरी LHS बघितली, आता RHS बघायचं. सिन्स मॅट्रिक्स A is 2 3 1 2, therefore determinant of A is equal to 2 into 2 minus 4 minus 3 into 1 minus 3 is equal to 1, and here also adjoint of A, adjoint here matrix diagonal elements are same, and therefore 2 2, and non-diagonal elements interchange their sign, therefore minus 1 minus 3, therefore A inverse is equal to adjoint of A divided by determinant of A. Here also determinant of A is 1, and therefore A inverse is equal to 2 minus 3 minus 1 2. Now matrix B is 1 0 3 1, and therefore determinant of B 1 into 1 1 minus 3 into 0 0 is equal to 1. Now adjoint of B, in matrix B also diagonal elements are same, therefore 1 1 remains unchanged, and non-diagonal elements it changes their sign, that is minus 3 and 0, and therefore B inverse is equal to adjoint of B divided by determinant of B, and therefore B inverse is 1 0 minus 3 1. Then we take product of B inverse and A inverse. RHS is equal to B inverse A inverse. Substitute the values of B inverse and A inverse, and therefore 1 into 2 2 plus 0 into minus 1 0, 1 into minus 3 plus 0 into 2 0, minus 3 into 2 minus 6, 1 into minus 1 minus 1, minus 3 into minus 3 9, plus 1 into 2 2, and therefore resultant matrix is 2 minus 3 minus 7 and 11. Here is the equation number 1, and here is the second. Therefore from equation 1 and 2 we can conclude that LHS is equal to RHS, and therefore AB inverse is equal to B inverse A inverse. With usual notations, prove that A11 into capital A21 plus A12 into capital A22 plus A13 into capital A23 is equal to 0. And second result is A11 into capital A11 plus A12 into capital A12 plus A13 into capital A13 is equal to determinant of A. Now this is general result, and therefore we have to take matrix A as A1 B1 C1 A2 B2 C2 A3 B3 C3. Now the LHS is A11 means element in the place of first row first column, that is A1, into capital A21 means cofactor of the element in the place of second row first column, म्हणजे ह्या elementचा cofactor. By the formula this is equal to minus 1/2 plus 1 into the determinant obtained by deleting second row first column, that is B1 C1 B3 C3, plus A12 means element in the place of first row second column, that is B1, into the cofactor of the element in the place of second row second column, that is determinant obtained by deleting second row second column, that is minus 1/2 plus 2 into determinant A1 A3 C1 C3, plus A13 means element in the place of first row third column, that is C1 into A23, that is cofactor of the element in the place of second row third column, means we have to delete second row third column, that is remaining determinant is A1 B1 A3 B3, that is minus 1/2 plus 3 into this determinant A1 B1 A3 B3, and therefore this is equal to minus 1/2 plus 1, that is equal to minus A1 into this determinant B1 C3 minus B3 C1, plus b1 into, because minus 1 raised to 2 plus 2 is plus 1, a1 c3 minus a3 c1. Again here minus 1 raised to 2 plus 3 means minus 1, take it outside, therefore minus c1 into a1 b3 minus b1 a3. And therefore by multiplying, it is equal to minus a1 b1 c3 plus a1 b3 c1 plus b1 a3 b1 a1 c3 minus b1 a3 c1 minus c1 a1 b3 plus c1 b1 a3. And here these terms cancels each other, that is minus a1 b1 c3 get cancelled with plus a1 b1 c3 plus a1 b3 c1 get cancelled with minus c1 a1 b3, and plus minus b1 a3 c1 get cancels with b1 a3 c1, and therefore result is 0. This is equal to RHS, and therefore a11 into capital A21 plus a12 into capital A22 plus a13 into capital A23 is equal to 0. This is the property of cofactors. मी आधीच सांगितलेली होती ही प्रॉपर्टी तुम्हाला. कुठलाही रोच्या सर्व इलेमेंटला त्यांच्या करस्पॉन्डिंग इतर रोमधल्या इलेमेंटच्या कोफॅक्टरना मल्टिप्लाय करून ॲडिशन केली तर ती काय असते 0. Now here is the example. With usual notations prove that a11 into capital A11 plus a12 into capital A12 plus a13 into capital A13 is equal to determinant of A. Means here element into its cofactor. एखाद्या रोचे इलेमेंट्स आणि त्यांचा स्वतःचा कोफॅक्टर यांची मल्टिप्लिकेशन घेऊन त्यांची ॲडिशन केली तर त्याची व्हॅल्यू ही डिटर्मिनंट ए बरोबर असते. देअरफॉर सोल्युशन, लेट मॅट्रिक्स ए इज a1 b1 c1 a2 b2 c2 a3 b3 c3, and therefore LHS is a11 into capital A11. इथं a11 means first row first column चा element तो काय आहे small a1 into its cofactor means minus 1 raised to 1 plus 1 into determinant obtained by deleting first row first column, that is b2 b3 into c2 c3 plus a12 means element in the place of first row second column, that is b1 into minus 1 raised to 1 plus 2 row number plus column number into the determinant obtained by first row second column, that is a2 a3 into c2 a2 a3 c2 c3 plus a13 means element in the place of first row third column, that is c1 into minus 1 raised to 1 plus 3 into determinant obtained by deleting first row third column, a2 a3 b2 b3, and therefore by simplifying this is equal to a1 minus 1 raised to 1 plus 1, that is plus 1 into b2 c3 minus b3 c2. Here minus 1 raised to 1 plus 2 is minus 1, and therefore minus b1 into a2 c3 minus c2 a3 plus c1 into minus 1 raised to 1 plus 3 means plus 1 into a2 b3 minus b2 a3. Say this as equation number 1. Now RHS is equal to determinant A. This is equal to a1 into determinant b2 b3 c2 c3 minus b1 into determinant a2 a3 into c2 c3 plus c1 into determinant a2 a3 b2 b3. This is equal to a1 into bracket b2 c3 minus b3 c2 minus b1 into bracket a2 c3 minus a3 c2 plus c1 into bracket a2 b3 minus b2 a3. Say this as equation number 2, and therefore from equation 1 and 2 it is seen that LHS is equal to RHS, and therefore the result A11 into capital A11 plus A12 into capital A12 plus A13 into capital A13 is equal to determinant of A. आणि याबरोबरच आपला मॅट्रिक्स हा चॅप्टर कंप्लीट होत आहे.